This video is going to help you in setting up, using, and troubleshooting a firewall policy on the GE MDS Orbit. Let's get started. So I'm on the access point and we have a simple system. It's a licensed 100 megahertz narrowband access point and remote. And these orbits are configured in a more advanced setup, which I'm going to be covering in other videos. The reason for this setup is it gives me the ability to have separate policies between the bridge and the licensed radio network. In most default orbit configurations, the LN radio is actually a member of the bridge. A bridge, acting like a virtual switch, operates at layer 2 of the OSI model, connecting multiple network segments into a single broadcast domain. It forwards data based on MAC addresses without considering IP addresses, making it ideal for local networks where all devices need to communicate directly. In contrast, a layer 3 routed interface operates at the network layer, handling IP addresses and routing packets between different subnets. This setup requires routing protocols to determine the best path for data, making it suitable for larger, segmented networks where the inter-network communication is needed. By default, having your LN radio inside the bridge simplifies communications as all devices are on the same network segment. Think of this as a virtual switch with virtual cables connecting virtually to all your remotes over the air. But moving it outside of the bridge to a routed interface offers better network segmentation and control, though it requires more complex configurations. On the Orbit, we can see our two interfaces on this access point, and we'll see that the bridge and the LN radio having dots are separate routed interfaces, with the Ethernet port being located under the bridge. My bridge firewall policy is going to be configured under the bridge interface, basic config, filter. And you can see here we're using an in-out trusted firewall policy, which we'll review in further detail, but just understand that this means anything in and anything out. Alternatively, my LN radio is using a different policy. Here we can go to basic config filter and see we are using a custom LN in untrusted, LN out untrusted. Having these two separate policies allows me for different control on the local bridge and or Ethernet ports and over the air. So let's take a look at the firewall service and some of the specifics. The first thing to note is under the firewall service status tab, we have filter status. The filter status allows us to get a really quick view of which rules under which policies are actually being triggered. For example, if I run a ping in the background, we should see that show up. So here we see my LN radio policies have been triggered. That's because I was pinging the remote orbit. And in order to reach my remote orbit, I needed to not only go through my bridge policy, but through my LN radio policy. So we can see here where my in-trusted policy would have increased, out-trusted would have increased, but then additionally my LN in untrusted policy was triggered, ICMP, and my outbound was triggered, ICMP. And there you have it. This is another just great insight into if your policy rules are being triggered. This may help you with identifying security flaws, holes, and or just functionality testing. So now let's take a little more look into our firewall's configuration. So the firewall service by default is enabled. However, it's set to in-out trusted, which means it's running, but it's not filtering any traffic. It's not necessarily doing anything. The problem with having a firewall filter that's not doing anything is, A, we're allowing security risk to potentially come onto the network, as well as we're allowing just traffic in general. So it's not just a concern of security, but a concern of throughput. So first off, you'll notice we have an enable checkbox suggesting the firewall is enabled. And then we also below that have UDP SPI enabled. UDP stateful packet inspection is a firewall feature that tracks the state of UDP traffic sessions. When UDP SPI is enabled, the firewall monitors UDP traffic, ensuring that only packets that are a part of an established session are allowed through. This helps in preventing certain types of attacks and ensures that only legitimate UDP traffic is permitted. The address set is a collection of IP addresses grouped together under a single name. Address sets are used to simplify the creation and management of firewall rules. Instead of defining rules for individual IP addresses, you can define a rule for the entire address set, making policy management more efficient and organized. And you can see here by default, we do have a local nets address set with the default IP address of the radio. And this is the network address. So essentially, if we were to use this local nets in our firewall policy, it would allow us to simplify by saying if the source local nets is, TCP drop, and then that would essentially say if it's in this address set, local nets address set, drop it. So that wouldn't be very good for us in this case because it would drop our local LAN. We would pretty much lose access to this network. But you could see where this is very beneficial for managing a firewall policy, as you can just simplify by saying group name and then allocating addresses within the group name so they're not sort of stuck in the firewall policy and you're just managing your address sets instead of your actual policy. And this applies for IPv4 and IPv6. Filters, or ACLs, are used to permit or deny traffic based on these criteria, enhancing network security and throughput by allowing administrators to define which traffic is allowed or blocked. Destination NAT is Destination Network Address Translation, DNAT, and this is a technique used to modify destination IP addresses of incoming packets. So DNAT is commonly used to redirect traffic destinations for specific IP addresses to another IP address, often to distribute traffic to different servers or route traffic through a firewall to an internal server. Source NAT, or SNAT, is a technique used to modify the source IP address of outgoing packets. So SNAT is typically used to allow multiple devices on a private network to share a single public IP address when accessing external networks, or to hide internal IP addresses of devices within a private network. And finally, we have static NAT. Static NAT address translation involves a one-to-one mapping between a private IP address and a public IP address. Static NAT is used to ensure that specific private IP addresses always map to the same public IP address, providing constant access to internal devices such as servers from external networks. Today, we're really just going to be covering address set and filter, as these are the most important two metrics in the firewall service that I think most users on a radio network are going to come across. The Orbit's firewall is very feature rich, and we have a lot of options available to secure and tweak a network in a way that's advantageous for your architect. So let's take a look at the filters. So first off, you're going to notice we have our filters listed on the left column and our references listed on the right. The reference gives us an indication as to where this policy has been applied. So you can see here our untrusted is referencing the bridge, which we've seen earlier, as well as the outtrusted. And again, you can see where the LN in and the LN out are referenced under the LN radio interface. Now the Orbit by default includes the in-trusted, in-untrusted, out-trusted, out-untrusted. And the reason for this is the GE gives you a default policy based on trust. So they give you a default trusted policy and a default untrusted policy. Now there are rules pre-applied into these policies, and the reason I've created my own new separate policies is to sort of further distinguish them from the factory setup. So in case, we wanted to use those for something else, or if the customer wanted to just have sort of a default reference. So let's just sort of review the default policies first. So we click on the policy, and then we'll see below the filter details. If we scroll down, we can see that the in-trusted policy is very simple. So this is the hierarchical order in which a firewall policy is triggered. So this policy allowing any protocol from any source to any destination, and that's defined by the action, which is to accept. So we are accepting anything from anywhere in the in-trusted policy. So let's look at the out-trusted policy. So again, our action is to accept any protocol to any source to any destination. So if you're using an in-out trusted policy, you're allowing anything in, anything out, and we're not filtering that traffic or hindering that traffic in any way. Now, alternatively, we have our default in-untrusted policy. Now, the first thing to look at is the Rule 10. If you noticed on the in-out trusted policies, they started by Rule 10. The policy type really is determined by this final rule. In trusted policies, the final rule is to accept. In the out trusted policy, the final rule is to drop. So, if GE gave you a Rule 10 policy only for the in untrusted policy, well, what would happen is as soon as you applied it, you would essentially lose access to the orbit, because at that point it would just be dropping everything that came into the orbit, including you trying to connect to it, right? So the default policy sort of takes precautions to not lock you out of your device. So the order of operation 1, 2, 3, 10 is determined by the firewall policy rules and how they trigger. So when traffic is coming into our in untrusted policy, it hits Rule 1, then it hits Rule 2, 3, and then 10. So the first rule that it comes across is the protocol ICMP? If it is, accept it. And it is okay for any source to any destination. So you can ping any source from any source to any destination, no problem. Rule 2, if the protocol is UDP and the source is specifically DNS, so a dynamic name server, and this is a default policy for cellular orbits because you need this in order to access the internet. So if it's UDP and it's specifically DNS to any destination is acceptable. Rule 3, TCP. If the source is any, so any TCP that is specifically going to the destination of HTTPS, NetConference, or SSH is accepted. The difference between source and destination is where it originates from and where it's going. Just to clarify, the source is the IP address or range of IP address where the traffic originates. In other words, it's the starting point of the data packet. The destination is the IP addresses or range of IP addresses where the traffic is headed. It is the endpoint that the data packet is trying to reach. So now let's look at the out untrusted policy. The out untrusted policy is different than our in trusted. So in the in untrusted policy, we were specifying destination ports or services that we were allowing into the orbit. And then we were dropping everything else. In this case, we're allowing only local nets. So we have an address set configured, which is our local nets address set, which we saw before, which specifies 192.168.1.0. So anything on the 1.0 network, if it's a source, and again, this is from outgoing, this is outgoing traffic. So if it's originating from the orbit or behind the orbit, and it is specifically in the 192.168 network, then it is allowed to any destination outside of the orbit. So this is a catch-all, and basically, as long as the untrusted services are originating from our orbit, which is 192.168.1.2, which is a part of the .0 network, then they will be allowed out of the orbit. Problems can arise is if you change your default IP address of the orbit without modifying the local net's address. So you could imagine if we were changing the orbit to a 2.1 network and we did not modify this local nets and we applied these policies to our bridge, we would then suddenly lose access to the orbit. We could potentially ping the orbit, but we would never get a response. We could connect to the orbit, but we would never get a reply. So this can be a problem if not sort of recognized and at least modified or tweaked in advance. You'll notice that under the source address set local nets, we also have an addition of add interface address true. Add interface address true in a policy configuration means that the policy rules will consider the IP address of the specific interface associated with the traffic flow, allowing for more granular and dynamic adaptation to interface changes. So in this case, the orbit's IP address is 192.168.1.2, but let's assume the orbit's interface is 192.168.2.1. And let's also assume that our local net's address set is still configured as the default 192.168.1.0 network. If the add interface address true is enabled, that means that it will add the IP address of the interface, the bridge, to the policy, essentially adding the 2.1 address into the rule as well. So this would ensure that if we made the change to our orbit IP address without making the change to the local net address group, we would still be able to access the orbit because we're allowing the interface address into this policy as well. So this is really just a safety precaution that they've given you to ensure that if you're not familiar with these address sets and you make that change and apply this policy, you don't lock yourself out of the orbit radio. So now let's take a look at my ln in untrusted and ln out untrusted policies. And in these, we're actually going to dive a little deeper into the actual setup of a policy and what makes an actual filter rule. So on the ln interface, I'm using my specific in and out untrusted policies. And these are much more detailed and bigger policies compared to defaults, as you can see. So here we have our sequential order, and we have a total of 10 rules. And again, this is an untrusted policy, so our last rule is a drop everything. And in my case, my in and out policies are identical. I basically filter inbound and outbound the same way. You also notice I do not have address sets used. Now, generally speaking, I work with and prefer to use address sets where applicable. They are a really great way to simplify and advance and increase the security of a firewall policy. But in this particular instance, simple is much easier for testing, and I always recommend you sort of start with a basic policy and then tighten the security wrench after you've sort of validated your tests and you have it working, right? So you can see here, our first rule is very similar to our default policies. We allow TCP to HTTPS and SSH destinations, and we've removed the net conference. Our second one is we allow ping from any source to any destination. We allow protocols. So default policies do not allow for industrial communications or protocol ports. So my sort of template policy, which I'll make available to you on our blog website, includes 3 common protocols. It includes EthernetIP, so TCP 44818 and port 2222. And actually, this is a mistake. This actually should be UDP. It includes Modbus, TCP, and Modbus UDP. The default Modbus port is 502, but for some reason, I just like to do 502 and 503. And then we include DNP3, port 20,000, TCP, and UDP. So for the LN interface radio, my default policy allows Modbus, EthernetIP, and DNP3. Now, ideally, if you're not using all 3 protocols, you probably wouldn't want to allow all 3 protocols. But again, this is a default policy that's used to sort of start your process, and then you would fine-tune this by deleting, removing, and modifying to shape your actual network architecture. And then finally, we have our proxy service ports. So TCP to port 30,020, 30,180. So the MDS Orbit has a web remote services proxy service that allows us to load our remote devices using the local Orbit's web server and limiting the amount of images and downloads that we are collecting from the remote and populating that information using the web server and local graphics from the local Orbit. So in order for this service to continue working, we need to allow it in our firewall. And then finally, we drop all of our traffic. So let's just take a look at these actual policies and how they're set up. So first is rule 1, which includes HTTPS and SSH. Now these are specifically referencing service ports. So the Orbit has built-in services that sort of simplify your setup for a policy. So every destination is a specific and unique port, right? So, and it's always the destination port that is unique and specific. The source port, on the other hand, is generally randomized and not unique. So when filtering traffic, we're always generally filtering the destination port or service. And in this case, our rule policy is protocol TCP, destination port is services, and then we have chosen HTTPS and SSH. We could easily add additional services like time NTP, network time protocol, SNMP, simple network management protocol, TFTP, and the list goes on. So this is these are built-in port assignments in the orbit that just make it easier for you to identify and locate a port rather than knowing the specific port number. Now again, we're doing HTTPS and SSH. So we talked earlier about the filter statistics and seeing how policies are firing. By having these grouped in together, we won't be able to actually granulate which one of these two is actually triggered, right? So HTTPS and SSH will trigger the same statistics, whereas if we isolated these and separated these policies, then we would know which one actually is being triggered. So that's just a tip and something to be aware of. And then so finally, after we choose our destination port, we choose actions, accept, and finish, and then we've created our policy. So now let's take a look at one of our manual policies. So this one is actually correct. This should be UDP. So let's just take a look at this one and go ahead and modify it. So you can see here we have a rule. The protocol is TCP. The destination port is a port range. So in this case, GE does not have port 2222, which I believe is the configuration port used, or an older EthernetIP port used on Allen Bradley PLCs. So we have to use port range, and we have to manually assign the port. And then again, we choose actions accept. Now, again, this one's a mistake. This actually is a UDP protocol. So we're going to change that to UDP. And now our filter is going to be looking for and only accepting UDP traffic on port 222. So now if for whatever reason we try to poll using 2222 on TCP, that would no longer work. And you'll see from the port range, so this is an example of how we can do ranges. So you can see here we're doing Modbus UDP. We have UDP protocol. We have a list of different things. So you're going to see ICMP in here, GRE. These are all protocol types. In this case, we're doing UDP. We have a port range. And then we just use a hyphen to specify a range of of port assignments. We can also do things like commas if we wanted to add additional ranges. So we could, add 602, 605 with a comma. We could hit finish, and now this policy would allow UDP from 502 to 503 and 602 to 605. Pretty much it. So if we were to look at my untrusted policy, we would see that it's pretty much a cookie cutter copy of the previous policy. Okay, I stand corrected. So you can see where we have a local nets configured for port 222. So I believe this was a script error, but it gives us a great example of how to use address sets. So let's take a look at this policy. So policy 4 is showing UDP, address set is local nets, 222, and then we have our proxy service, which we have down here as well, right? So let's just modify this. So we're already accepting our proxy service. So let's just make this our Allen Bradley protocol. But again, in this example, we're actually now also filtering the source address. And this is in our out untrusted. So the way this policy actually is working is we're allowing UDP 222 into the orbit. But for it to leave the orbit, it needs to be on our source network, which is defined by local nets. And then the destination is 222 accept. So the way this is set up currently is if I was being pulled on port 222 from a server, it comes into the orbit as any source. So it doesn't care where it originates from. Comes in, it goes to the PLC responds, and then now it's going out. So now it's going through our out untrusted policy. Before it can leave, it says, is the source, is that PLC, and where this is originating from, is that source on our local nets? If it is, and it's 2222, then it can go. If it's not, then this policy would drop the packet. So this policy doesn't necessarily make sense. Ideally, we wouldn't have like a rogue device responding, but that's essentially what this policy is doing incorrectly. It's filtering a reply, which it would make more sense to filter the incoming. So for a better example of using an address set in the orbit, we might take a look at this. So let's say, for example, we want only one server on our network to be able to pull 44818. So what we would do is we would go to our policy. We would say, is the source address set local nets. So now we're essentially saying if we're being pulled TCP from the 192.168.1.0 network on 44818, it's accept. If we were being pulled from 192.168.3.0 network, we would not accept this. If we were being pulled by a server on a 10.10 network, we would not accept this. Now we could come into our address set and we could modify this. So perhaps we have a specific server on a different network, 168.3.50/32. So in this example, we've added a specific device address. So the 32 represents all 32 bits, and it specifically says this computer at 3.50 is part of our local nets. So now if I was to ping 44818 from this server that's outside of our network, it would be okay. I could expand this further and I could just say 192.168.0.0/16. This would encompass the entire subnet, essentially collecting everything from 1 to beyond. So, address sets are very, very beneficial. They simplify policies. They're exceptionally well for cellular, where you're sort of filtering public internet traffic and you want to sort of, add additional security for things like, ping of death attacks, denial of service attacks, web management restrictions, things like that. So that's it. So, we've basically covered firewall policies, inbound, out trusted, and how we sort of apply those to the interfaces. So in this case, we are allowing Modbus traffic, EthernetIP, DMP3 traffic on the radio. We're allowing everything on the bridge. And the idea here is that we allow unrestricted access locally on the Orbit's network and Ethernet ports. But when it's going out over the radio network, we are only allowing very specific ports, and protocols. In a typical Orbit layout, the LN radio would be assigned under the bridge. So in that scenario, we wouldn't have a separate policy. This policy for the LN radio would be defined by the bridge. And then, therefore, we would apply our in-out untrusted policies to the bridge. The limitation of this is if we need to isolate radio traffic from bridge traffic, it's much harder to do. Because in this point, for example, if we were to block 44818 traffic, we would be blocking it over the air, but we'd also be blocking it locally. So we may not want to block local access to 44818 and only over the air traffic. So this is just a quick tutorial on the Orbit firewall, how to use the firewall, and hopefully it's been beneficial for you. I'll have a blog post accompanying this on our website, bcitech.com/blogs. You'll be able to get some of the template scripts for the firewall policies. And, I hope this helps. If you have any questions, you can always reach out to me directly. BCI Technologies, Philip Yancey, Sales Support Manager. My number is 407-847-8848, extension 204. You can reach me by email at sales@bcitech.com. Have a beautiful day.